All right, today we're going to continue on with our concept of collecting and displaying and analyzing data. Helps us to solve problems and understand the real world. We're going to continue with constructing graphs and analyzing data, but today our specific goal is going to be to choose the best type of graph, and we'll talk about a few different types of graphs. This is lesson 5. All right, so here we have Tao, who counted the number of red chocolates in 5 different boxes of candy. This is the data that he was collected. He displayed his data in a bar graph. He chose a vertical bar graph. So he has the number of red chocolates, he has the number of boxes, and so on. And here is his bar graph. Number of red chocolates. You have the box number here, the number of chocolates here. He's numbered by 2s on this side. He's numbered by 1s on the bottom. You can clearly see that box number 3 has the tallest. You can clearly see that box number 2 and number 5 have the same amount. You can clearly see that box 1 has the smallest amount. You can very clearly see the numbers of candies in each. Here we have a half of a box in this bar, so half between 8 and 10 would be 9, so we can see even 9 there. It's quite specific. Good that it was a bar graph, because we can't have half a chocolate, so it should be either a bar graph or a series of points, so he's made a good choice. Next we have Manuel, who's recorded the contents of his family's recycling bin. This shows his recycling bin for 2 weeks. Plastic items in week 1 and week 2, glass items week 1 and week 2, canned items week 1 and week 2, and so on. He wanted to compare week 1 and week 2, so he drew a double bar graph. 2 sets of data can be compared. Again, good idea to be a bar graph or a series of points. In this case, a bar graph is a better choice because you're comparing 2 sets of data. It is discrete data. You cannot have half of a can in your recycle. Well done. Has a title, Our Recycling Bin. Has a legend, week 1 and week 2. The item below, plastic, glass, cans, and boxes, nice and clear. Number of recycled items, and he's numbered by 2s. Highest set of data was 23, so numbering by 2s is perfect. Could also be by 1s. And from this bar graph, we could see that more plastic items were in week 2 than in week 1. We could be specific, and we could say, okay, in week 1 there was 21, in week 2 there was 23. So just 2 more items were recycled. Fewer glass items in week 2. Again, we could be specific about the difference. Fewer cans in week 1, more boxes in week 2, and we could be specific about those differences. Again, a good choice for graph for this data. Manuel then displayed the data to show the total amount recycled over the 2 weeks. So he's added those items together, a total of 44 items and so on. Still discrete data because we can only have 1 item at a time. And he's decided to do a pictograph where 1 picture represents a number of items. So each container represents here 4 items. So for the plastic containers, because there was 4 items in each, he would need 44 divided by 4, 11 containers, and so on. We can clearly see that in the 2 weeks, more plastic items than anything else were recycled. We could see that 4 more glass items were recycled, 8 more boxes were recycled, and so on. We can be quite specific. Also a good use of data. A good graph for this is a pictograph. Remember, when data is joined, that it's a line graph, and a series of points graph and a bar graph are very similar in the kind of data that they'll display, and either one is a good choice. All right, go ahead and practice. What type of graph would you use for this kind of data? And be sure to tell us why. Remember, a bar graph is an option, a double bar graph is an option, line graph is an option, pictograph is an option. So you can use any of those types of graphs. So take a moment, press pause, and decide what kind of a graph you would draw based on this data. All right, let's take a look. We have scientists who've been keeping track of the sea otter population because they're worried about the effect of the environment. So we have the number of sea otters probably taken every month or something like that. That would be discrete data because you can't have half of a sea otter. So probably a bar graph, a series of points graph would be your best choice. It could even be a pictograph. Secondly, we have how much water does the average person use each day? Well, we could have half a cup or half a milliliter or whatever. This is a measurement, and often when it's a measurement and not just something that can be counted, it is continuous data. So in this case, a line graph would be your best choice for this data. All right, now you get to practice. You are working on page 269, 270, numbers 1, 3, 4, and 6. Determine the best type of graph for each set of data, so choose the best one you can. Remembering all of the things we've talked about when graphing, that you need titles for the top and for the axis, so all three titles. Watch that your numbering or your scale is in intervals so that it's by ones or twos or whatever. Watch if it's continuous or discrete, whether or not you are joining dots or making a bar graph or so on. And away you go. Remember, if you have any questions along the way, that you remember to ask.